Okay, so hello everyone, this is Akshay here and welcome back to the another great day of our GFG period streak. Today's question is a very standard and an easy category question. So we need to find the maximum sum subarray of size k, right? So we've been given in an array with an input of 100, 200, 300 and 400. So the value, again, the size of the array is 4 and the k is equals to 2, right? So definitely what would be the approaches? Thus, first of all, we form all the possible subarrays of size k. Let's say the element would is given as 100, 200, 300 and 400, right? So the possible, so we will come at the first index and we'll form a k size array. Again we will come at the second index, form a k size array subarray, let's say. Again we'll come at the third index, form the possible k size array, right? So we are traversing each and every element, so that takes O of n, and then we are traversing k times for each and every element to form a subarray of size k. So it would be O of n star k as time complexity and space as O of 1, right? That would be your method 1. How can we optimize this approach? Then instead of forming the window uh, each and every time, we just form one window, and then we, for considering the next element, we add the next element, and then we uh, remove the first element of the window, right? So let's say you have a start and end pointer, right? And you'll have first k elements, so 100, 200. You'll have first k elements, and now the sum is equals to what? 300, right? Now the next window would look like that. You will have a third element here, 300, but the windows should shift to this one. This would be your new window, right? So in the existing window, you need to add your current element and remove your first element, right? So in forming a new window, what you need to do is that add current, add, let's say, the ith element, and remove the first element of your window, right? And again you need to maintain your max answer. So initially the sum was 300, so now the sum is 500, right? So previously the sum was updated to 300, then again we got a new sum which is greater than my 300, so I will update it to as 500. Now we'll have a next element, so the next element is 400, and now your new window will again shift to 300 to 400. And now the sum here is again 700, which is greater than your previous sum, so 700 will be your final answer, and that is how we are getting the answer in the output, right? So let's just see all the two approaches. Oh, not the brute force. We will not code the brute force. That is very easy. So I will not show you the code, but again I will give you the code in my source. This source code will be present in my GitHub repository. So I'll mention the link of that source code for the brute force as well, and you can go through that. But it is highly recommended, guys, to please try it yourself and then only move ahead with the optimized solution, and that is to by yourself. Okay. So that is the core in Java, that first of all we have a current sum variable and an answer pointing to min value, because if you want to maintain the track of max value, then definitely we have an answer uh, initialize as min, and vice versa. If you want to track the min value, then initialize your answer with a max one. We have a for loop which is going till k times, and we are adding the current elements in our current sum. Now again we have an answer variable, so we'll store the maximum value. Then for next of the window, what we'll do, that we'll have the iteration coming from I equals to k till less than n. We'll be removing the first element of window. How we can do that? So for that we have initialized a pointer j equals to 0, and whenever we are removing that first element, we are doing the pointer j plus plus, because this j plus plus will be the index of the first element of your next window, correct? And then we are adding the new element, that is the current ith pointer, and then we are again tracking the sum, the maximum sum, and we are returning the answer. So that is it. That is compile and run. So what is the time and space complexity for this code? Since we are using an explicit for loop which is going for k times and then going from k till n, so summing it up, it would be O of k plus O of n minus k. So again it would be O of n as the overall time complexity and O of 1 as your space complexity. Great, the code has been successfully submitted. Let us see the C++ code. Is the same as we have done in Java and C++, so yep, no need to explain it here. Great, yeah. So that was a very simple and easy question, I must say. And let us meet again in the tomorrow's GFG period streak. Till then, keep learning, keep growing. Bye bye, and take care, guys.